reasoning, and then there's going to be deductive reasoning in section 4. Okay. Inductive reasoning is where you make conclusions based on observations. Okay. For example, I walk in with this mug every day. You might induce that there's coffee in it, and then from there you would induce that I like coffee. But you don't have any facts that there's actual coffee in this mug. It could be tea, you know, but you could still make an inductive conclusion that I like coffee. Okay, just based on your observations. And now deductive reasoning is based on a set of facts. So induction is sort of like observations to make conclusions, so things that you're looking at, patterns that you might recognize, and then deduction is based on like set specific facts. So for example, you could say I'm trying to think of a good example for deduction. You could say that the average cost of going to Starbucks is $5. And if you saw that I had a Starbucks cup that like was the $5 price one every single day, then you could deduce that I was spending $25 a week on Starbucks. Because you'd have some facts. Does that make sense? So induction is observations and pattern recognition. Deduction is specific, true facts. Like solid evidence, more so. And they talk about, like, anybody ever read or watch Sherlock Holmes? Any version?
Yeah.
Okay. He's always talking about deduction, deduction, deduction. He's actually inducing, not deducing. Because he's basing his conclusions on, like, observations. Like, he'll see that somebody has, like, pen ink on them, and he'll induce that they're a writer or something.
So you said deduction?
Deduction is, like, set specific facts. Induction is by observation.
Okay, so he's observing. Okay.
He's observing, and so he's actually not deducing, he's actually inducing. Yeah, so it's observations. So I'll write that on here. Okay. Now the conjecture is the conclusion statement. Okay. So back to my coffee mug. You see me walk in here with this, you induce that I like coffee. So your conjecture would be, oh, Miss Ayton likes coffee. That's a conjecture. It's a conclusion that you come to based off of your observations. We can make conjectures from patterns. If we look at the movie show times, we have 8:30, 9:45, 11, 12:15. So our conjecture is that there's a movie every hour and 15 minutes. Okay. So then our next time would be 1:30 p.m. And then we could continue going and add an hour and 15 minutes, hour and 15 minutes, hour and 15 minutes until whatever time the movie theater closes. A little bit more complicated. We don't have, words, but what we have is this figure is made up of 4 lines, 1, 2, 3, 4, and then here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then I have my 10, 11, 12, 13, 14, 15, 16, 17, 18. So what am I doing every time?
Adding 2. Well, you go from 6, and then you add 2 more, so 8, and you add 2 more, which is 10.
Yeah, so we start with adding 6, and then each time we add 2 more. So Okay, so to go after 40, we're going to add how many?
6. 40, that's going to be
So
14.
14, we'll add 14. So if we're going to draw that, yeah, I'm just going to do these kind of like this. Yeah, it is. So 1, 2, 3, 4, 5. Okay, so here's our 40, and then I'm going to add 1. So I would now have 54. And then if I had to keep going, my next one, I would add 16. Yeah.
Why is the line dotted?
It's hard to tell in this picture because I scanned it so it didn't scan well, but these are dashes. So it's just saying how many pieces you added, how many dashes you added to the figure. But I had to scan it, I couldn't recreate it. Because
How do you know if we come up to a question like that,
well,
how do we know that's what they're asking? Because some people would say they're lines.
Okay, but here, look at the numbers. You've got 4, 10, 18, 28, 40. So that's what we looked at to come up with how many we add each time. Does that make sense? So, and then on your picture, like whatever you would have to work with is going to be a better rendition than this. I'm not going to give you something like that's not clear visually and expect you to be able to do it. So it's like if you look at your packet, your pictures are really clear. So, even with the dots and stuff, they're really clear. Everything's. Here, we're going 10, 4, -2, -8. What are we doing to go from each of these to the next one? To go to 10 to 4, how do I get there?
Subtract 6.
Okay, and to go from 4 to -2?
Subtract 6.
So I'm subtracting 6 each time, so that would be my conjecture is to subtract 6 each time. And then my next item in the series is going to be -8 minus 6, so -14 is the next. Okay, when I have a picture like this, I have one triangle. Now I have 4 triangles. So 1, 4. Now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Ooh, I forgot this triangle. I'm sorry.
Wait.
There should have been a triangle in there. I left one out.
Okay, I see your point.
13, 14, 15, 16 triangles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I left one out.
Oh, okay.
Yeah, I accidentally left one out when I drew this. Okay. So how many triangles would be in my next figure? Well, what do I do to get from a 1 to a 4 and a 4 to a 16?
Multiply by 4. So that's going to be like.
So to get to the next figure, I'm going to multiply times 4. So the next figure would have 64 triangles. And in order to create that, this is what we would do, just so you could see it. You don't have to do this. We put an upside down triangle inside. Or, alternating triangles. And then if I counted all of those new triangles, there would be 64. But if you can tell me that there's going to be 64 triangles, you've recognized the pattern, you're good. Take a minute and look at the 4 problems here and then see if you can find the pattern, write the conjecture, and find the next item in the sequence. And then we'll go over them together. Question, what did you guys recognize for the pattern? A 3. Why are you doing this? Yes, I see that. Okay, so we found the patterns. Are there any questions on these at all? No? When we talk about algebraic conjectures, we're talking about numbers and variables. And when we talk about geometric conjectures right now, we're talking about shapes and patterns and pictures. Okay, so if we want to make a conjecture about the sum of two odd numbers, well, let's just pick some odd numbers and see what happens. So 1 plus 3, 7 plus 11, 19 plus 5. So I'm just picking any odd numbers, and what am I getting when I add two odd numbers together? Right? So every time I add two odd numbers together, I'm getting an even answer. And if you need to try a couple more, you can. But every time we add the two odds, I'm getting an even. So my conjecture is that the sum of two odd numbers is even. Okay. All right, and I could do segments joining the opposite vertices of a rectangle. Well, I gotta look at that. So I'm gonna draw some rectangles, just random, different size rectangles, and kind of see where it takes me. And I want to look at the segments that join them, the opposite vertices. So opposite vertices are the corners. That's not in the corner. Okay, close enough. Okay, and if I look at those two line segments going from corner to corner, what can I say about them? Or what can I decide about them? Or what do they look like? Any ideas so far? Hmm?
What was that called again?
Well, okay, let's look at these angles. Don't look the same as these angles, do they? So I don't see any pattern there. And then, so the angles aren't the same in all of the rectangles. And when you look at the angles inside the rectangle, the vertical angles are congruent because vertical angles are, but they're not all four of them congruent, so I can't say anything about that. The pieces in the corner, the angles that it makes up there, those don't look the same either. So we want to look at the segments. And what we're going to do is we're going to grab a ruler. We're going to grab giant ruler because we're up on board. Okay, if I measure this length, it's about 14 inches up here. And if I come over here and I measure this length, about 14 inches. So I'm going to try these two on the next one. 16, 16, 11, 11, So we just want to try different things. Look at the angles, measure the length of the lines, you know, anything that you can do like that. And in this case, when I measured the length of the lines, I found out that the segments, yeah, the segments were congruent. There's, you know, or the same length. You could say that. You could say the segments are equal. But no, I wouldn't just look at that and go, oh, those are equal. I would have to, you know, try a couple different things, like check out the angles, check out the lengths of the segment, see, you know, what we can figure out. You might have noticed when you were doing your measurement that this length and this length are the same, and this length and this length are the same. So your other conclusion, maybe you don't get the segments are congruent, maybe you say the segments bisect each other. Maybe that's what you discover. There's going to be more than one possible correct answer in a situation like this. So we'll try adding even numbers together. 2 plus 6, 22 and 10. Yeah. I'll just call it a conj. Is that the sum of two even numbers is even. Okay. Okay. To do this next one, we first have to know natural. No, shoot. I left out a word. I'm sorry. I should say consecutive.
Like, why would you consider that?
Okay. We won't. The sum of the squares of two natural numbers won't actually give us a pattern, but the sum of the squares of consecutive natural numbers will. So natural numbers are the counting numbers. We start at 1 and go up from there. There are no zeros, no negatives, because it's natural counting. Consecutive means to go in order. So 2 and 3 are consecutive, 10 and 11 are consecutive, just the two numbers that are in order. So we're going to try some. I'm going to start with the smallest 2. And I'm going to 1 squared plus 2 squared. That's 1 plus 4. So that's 5. 2 squared plus 3 squared. That's 4 plus 9. That's 13. 3 squared plus 4 squared is 9 plus 16. That is 25. Do you guys have a conjecture yet? What are we looking at? We've got all these. I'm taking two numbers in order, squaring them and adding them together. And what are my answers all?
Odd numbers.
Odd. So you might have to do a few of them to see if you can recognize the pattern, but our conjecture.
So those are natural numbers we're squaring?
No, the sum of the squares of two naturals. Yeah.
Okay, so natural numbers are
just your counting numbers. Yeah, so natural numbers, because if they come naturally, you start counting at 1. That's natural, right? That's why they're called natural numbers. Consecutive natural numbers is odd. Okay. And like I said, sometimes you can do 1 or 2 and you see the pattern. So these are the 4. It's going to take time to go. I drew the picture, A, B, C, and then I put D in between the two of them. And the only thing I could come up with was that that makes D collinear to A, B, C, and so A, B, C, and D are all collinear, because I don't know anything about how far apart they are, so I can't say anything about congruence but because D is between B and C, it puts it on the same line. So I said they're collinear, all of them. P is the midpoint of NQ, and the only thing that midpoint tells me is that this length and this length are the same, so you could have said NP is congruent to PQ with the segments, or you can say without the segments that they're equal. The lengths are equal. Really had nothing else that I could come up with on that one. 1, 2, 3, and 4 form 4 linear pairs. So I've got 1, 2, 3, 4 linear pairs.
When it's linear, it's
A straight line. So, but to get 4 linear pairs, I have to do, this is the only way I could draw that, to get 4 linear pairs.
okay.
So then I could come up with conjectures that 1 and 3 are vertical, 2 and 4 are vertical, 1 is congruent to 3, 2 is congruent to 4, or I could come up with the fact that when I add 1 and 2, 2 and 3, 3 and 4, and 4 and 1, I get 180 degrees, because linear pairs add up to 180. So I have 1 plus 2 is 180, 2 plus 3 is 180, 3 plus 4 is 180, 4 plus 1 is
Oh,
180.
okay, I see, because they're all
Yeah.
straight lines.
And if you numbered them differently, maybe 1 and 2 ended up vertical or something, but it would be based on the picture you drew. So there's a couple different things we could get from this one. There's a few different conjectures that could be made. You don't have to have all of them. These are just possibilities. And then angle 3 being congruent to angle 4, really the only thing that told me was that their measures were equal. I would need more to go on to come up with anything more than that. From data. Okay, so we can use data sets to make conjectures, to make, to come to conclusions. Now, there's an owner of a hair salon, and I'm assuming she, could be he, they collected data on the number of customers, her salon had each Friday, Saturday, and Sunday for 6 months to decide whether or not she should increase the number of stylists working each weekend. So here's her data. On Friday, in month 1, for Saturday, Sunday, month 2, we went up. We went up, we went up. We come here, we've gone up, we've gone up, we've gone up. Okay, so every time, every month, it's going up, the number of people coming. So our pattern is that the number of people are increasing. And what this tells me is that the number of hairstyles are increasing, because nobody's going to come to the hair salon to just chill. They're getting their hair done, right? So what conjecture could we make in regards to whether or not she should hire additional stylists for the weekend? If our numbers are going up every weekend, do you think she needs more people?
Depends on how many people she started with.
Well, that's true, but just based on what we have, the information we have.
Yeah, I get it.
Yeah, just based on the data we have, she should hire more stylists for the weekend. Counterexample is any example that proves a conjecture false. So let's go back to the coffee. let's say that your conjecture was that I drink coffee every day. All I would need to do is bring in tea one day, and I've proved your conjecture that I drink coffee every day false. Now, I don't necessarily have to even bring in tea, but the possibility that I can bring in tea proves your conjecture false. Okay, so all we have to do is find a counterexample to show that a conjecture is false. It only takes one to prove the entire statement false. So we need to find one counterexample. Oh my, I had to fix my typo. Sorry, I just saw that. That's bad. There we go. If we find one example false, just one, then we've proven the whole statement false. Now this first one's a little tricky. So if n is a real number, then n squared is greater than n.
It can't be true. Well, it can't be true.
Well, and it's not true, but if you start thinking about, like, most people start thinking in terms of whole numbers or integers. And if I take 4 squared, I get 16, or if I take, you know, negative 3 squared, I get 9. I just need to find one example, though, that makes this not true.
1 times 1 squared is not greater than 1.
1 squared is not greater than 1. This is a counterexample. It's not greater than 1. Fractions would also work, because if I take 1/2 and I square it, I get 1/4, and 1/4 is not greater than 1/2. Yeah, 1 squared is not greater than 1. In this case, 1/4 is not greater than 1/2. So I could find an infinite number of counterexamples, but as soon as I found this first one, I've proven it false. Okay, if JK is equal to KL, then K is the midpoint of JL. I can draw a picture. If I make this K and this J and this L, and I say that these two are congruent, K is not the midpoint.
You don't have to draw a straight line, right?
No, I don't have to draw. I'm trying to find any kind of example that would prove this false. I could draw a triangle. It's an isosceles triangle. K is still not the midpoint. I could draw any kind of angle. I could draw a square and make J, K, and L vertices of the square. I mean, I can do any kind of bent line or line segments that don't put K in the center, don't make it the midpoint on a straight line, but you have the two lengths the same, is a counterexample. So just draw like that. Those are the same, not a midpoint. Because it has to be on a straight line to be a midpoint, but
Because it's the midpoint of JL.
yeah.
It's not.
No, it doesn't necessarily mean it is. Okay, if n is a real number, then negative n is negative. Well, if I already make n negative, then negative n is going to be a negative of a negative, which is going to be positive. There's my counterexample.
Or 0?
Yeah, I could have used 0 also, because there's no such thing as negative 0. Right? So if n is 0, negative n is also 0, because there's no negative 0.
Exactly.
So that would also be a counterexample. If ABC is congruent to DBE, then ABC and DBE are vertical angles. Not necessarily. I could use John's right angle. I'll call this A, B. Oh, nope, that I won't be able to do. Sorry. can't draw that because I can't label it correctly. But I could say A, B, C, and I could have D, B, E, and I could say that this angle and that angle are congruent. They're not vertical. So any picture that you can draw where you label these two as congruent, where they share a B, but they're not vertical, is a counterexample. Again, on the worksheets. And we're going to decide if it's true or false, and if it's false, we're going to give it a counterexample. So if ABC and CBD form a linear pair, then they're congruent. If AB, BC, and AC are congruent, then they're collinear. If AB plus BC equals AC, then AB equals BC. If 1 is complementary to 2 and 1 is complementary to 3, then 2 is congruent to 3. So see, decide if they're true or not, and if they're not true, come up with a counterexample. Okay, so number 9, is that true or false? I got about half and half, but it is false. Because I could draw it. They have to form a linear pair, right? They just have to be on the same line, but they don't have to be the same size. So here's angle ABC and angle CBD. Right, it just says that they form a linear pair. So if I can draw a picture where they do form a linear pair, but they're not the same size, I can prove it false. Okay, how about if AB, BC, and AC are congruent, then they're collinear? False. What'd you draw?
I just drew them on the same plane.
Okay. I would do a triangle, personally. A, B, and C. Equilateral triangle. But you could do A, B. Well, no, it kind of has to be a triangle, or because the points are shared. So.
No, it was a triangle on that.
Number 11, true or false?
True.
If AB plus BC equals AC, then these two have to be equal to each other?
No, that's false. Because AB could be 10 inches and B to C could be 28 inches, and it's still get the same and equal 38, and then but A and B would not equal B to C.
AB plus BC equals AC, but they're not equal. So
it would only be true if they were all equal.
It would only be true if B was the midpoint between A and C. Okay, if 1 is complementary to 2 and 1 is complementary to 3, then 2 is the same as 3.
True.
That is true. Because complementary means we add up to 90. So if angle 1 and angle 2 equals 90, and angle 1 and angle 3 equals 90, well, this has to be the same because these are the same, correct? So number 11, there is no counterexample because it's a true statement. Or not number 11, sorry, number 12. See, can't even count today. Okay, any questions?